Welcome back to our ionic compound chapter. In this set of to be Section 2, we're going to look at the formation and properties of ionic compounds. And the questions we should be able to answer is how are ionic compounds formed? So we will show that using electron dot structures. And then what are the properties of those ionic compounds? Alright guys, remember ions are formed when neutral atoms gain or lose electrons to achieve stability. When this happens, the positively charged cation is attracted to the negatively charged anion, like two magnets, one positive, one negative. They're attracted to one another. And an ionic bond is formed between those two atoms. This is a very strong bond that will affect the properties of the compounds being formed. Compounds that contain ions are called ionic compounds, and these result when metals react with nonmetals. Ionic compounds are neutral, and that means that the plus charges must equal or balance out to the negative charges. So we show the formation of sodium chloride by basically we're doing the electron dot structure for the metal. We add a plus sign, the electron dot structure for the nonmetal, and then we're going to have an arrow, and then we're going to show the finished product. So we've done this separately when we form just the cations, and then we form just the anions. What we're doing here is we're just merging the two together. And then we see an ionic bond is formed by the positive and negative charged sodium chlorine. This is showing the transfer of 2 electrons from magnesium. Oxygen needs to gain 2, magnesium needs to lose 2, and then we see the final product. So this is what we're going to be doing in class today. Oh, this is another slide where we've got a little bit of, it didn't really format very well. Sorry about that, but sodium chloride and magnesium oxide are called simple ionic compounds because in each of these cases, the number of electrons that the metal needs to lose equals the number of electrons that the nonmetal wants to gain. But this is not always the case. For instance, in these two examples, they need to gain or lose a different number than the other atom wants to gain or lose. So sodium oxide, for instance, sodium only wants to lose 1. Oxygen wants to gain 2. So what we're going to do is bond oxygen to 2 sodium atoms, and that will allow each of these to be stable once that process is complete. Magnesium chloride, magnesium wants to lose 2, but chlorine only wants to gain 1. So we will bond magnesium to 2 chlorine atoms so that in the end, all 3 of those products, the compound that's formed between all 3 atoms, are stable. So looking at the electron dot structure for these atoms, for these compounds, we have 1 potassium and 1 iodine. So I am going to start by writing out the symbols, and then I am going to draw the electron dot structures. Potassium is in group 1A, it has 1 valence electron. Iodine is in group 7A, it has 7 valence electrons. So those are my electron dot structures. Now what I have to do is show the transfer of the electrons. So I circle the electron being lost, and I put an arrow to where it will be gained. And then I'm going to draw my something happened arrow. And then I'll go back and write the final product. So potassium lost and gained a +1 charge. Iodine, however, gained, and it gained so that it has all 8, and it ended up with a 1- charge. So there's our potassium iodide. Magnesium bromide, we have magnesium and 2 bromines. That's what the 2 says. So we're going to put 1 here and then put the other one just underneath it. Now, forming the ionic or the electron dot structure, magnesium has 2 electrons. Each of these bromines have 7. And then we circle the electrons being lost and show where they're going to be transferred. We cannot transfer it to a side that has 2. We have to transfer it to the side that only has 1 for each of those. And then we're going to show what is formed, our compound. So magnesium lost 2, it gets a 2 plus charge. Each of our bromines, we have to write those out again, but each of those bromines gained an electron, so they each have 8. And because they each gained 1, they now each have a negative charge. All right, K2S. Our K plus the S. Doing the electron dot, K is only got 1. S has 6. Again, circle and show the transfer. One will go on that opening side, and the other one will come here down on the bottom. And then our final product, each of our K's has a 1 plus. And then our S has a full set of dots, and it gained 2, so it has a 2 negative charge. All right, the properties. You need to know these 5 properties. Most ionic compounds have a crystalline solid at room temperature. They are hard and they're brittle, so they shatter when they are hit. They have high melting and boiling points. That's because they're very strong bonds and they require a lot of energy to break those bonds. They are usually soluble, which means they can be dissolved in water, and that's how we make those electrolytes, is by dissolving the ionic compounds in water. And then ionic compounds do not conduct electricity when they're solid, because those ions are packed so close together in that crystalline solid and they can't move. But once they are dissolved in water and form those electrolytes, they can conduct electricity. So they can conduct as a liquid, but not as a solid. This to the left is showing you that crystalline solid that we were talking about. It's a very highly ordered and organized structure, and there's not a lot of movement between the atoms. And then you see in the black that solid piece of salt, because this is salt, and we then process that or refine it so that we get our table salt that we put on our food. Yum, yum. And then I really love this Kim Cat joke. He threw sodium chloride at me. That's a salt. Get it? Ha ha ha. And then just some true-false concept check questions. Ionic compounds only contain nonmetals. Hopefully you realize by now that they are a compound between a metal and a nonmetal, so that is false. Ionic compounds always conduct electricity. That is also false, because they only conduct electricity in their dissolved state. A lot of energy is needed to break ionic bonds. That is true. Remember, in order to break those bonds, it requires a lot of energy, so that because they're a very strong bond. And then ionic compounds are soft. False. They are very hard and they're brittle. They shatter easily. Ionic compounds are usually soluble in water. That is true. They do like to dissolve in water. And then ionic compounds form gigantic, or giant in this case, structures. And then that's true. They form gigantic ones. I don't know if you've ever heard of salt mines, but if you Google that, you're going to see that salt can form huge structures. And most ionic compounds can. All right, thank you. We are done with section 2. That was very rushed, but class is about to start. So I will see you later for section 3. Thank you.